So welcome to those who've just joined. Today we're talking about how you can manage your project risks using reality capture and what is scan to BIM actually and how do you go about making use of it. So in terms of the agenda and what we're going to be talking about, I'll start off with an introduction, just describing very briefly what reality capture is, why you should use it, and also importantly, when is it appropriate to use these workflows. And then we'll get into the how of it, particularly breaking it up into the three main portions of the workflow, the capture portion, moving on to compute, and then creating your actual model or drawing, which is essentially your deliverable at the end of the day. And then we'll finish up with just a very short summary and look at how we as Baynes can help you along this journey. At this point, I also just want to mention that we have a YouTube channel as well, where we have tons and tons of information, particularly related to Scan to BIM, done by one of my colleagues. So you're welcome to go and check out our YouTube page, subscribe to it. There's lots of interesting things on there. And then introduction about myself. I am one of the technical specialists here at Baynes. I have a structural background. My previous experience is in the Revit modeling, working with the BIM 360 on the administration side. And my area of expertise is in multi-story residential, industrial and educational buildings. I've also worked on a couple of renovation projects where we did use the scan to BIM workflow, and I can really say that it is such a game changer. Once you start using these tools and these processes, it's really hard to go back. And then in terms of Baynes, a little bit of an introduction for those of you who don't know Baynes. Baynes is a partner of Autodesk selling their software, but in addition to that, we also do a lot of other we service the industry in some other ways as well. Scan to BIM services is one of the things we're quite excited about. Not only do we provide hardware as well as the consultancy thereof, but also training and assistance with the on the software side as well. And then another thing that we're quite passionate about is our blended learning approach. And I'm going to just move over to the next slide and talk a little bit about the product. CAD Learning is one of the products that we sell in addition to the Autodesk software. And that is kind of like an online platform that assists with that blending learner approach, where we've got classes as well as virtual assistants. And then some of the products I'll be talking about today is not only on the Autodesk side, but also Leica in terms of the scan hardware. And then I'll also talk about Clear Edge, which is another set of tools that are available in the Scan to BIM workflow. So now that you know a little bit about me and a little bit about the company, I want to know a little bit about the audience. So I'm going to launch a poll, 2 questions. The first one is, how much alteration versus new build projects do you typically work on? Do you work on only new buildings, mostly new, more or less the same between the two, mostly alterations? That can be in the form of renovations or extensions, internal changes, or solely alterations. Okay, just give it a couple of more seconds. Okay, cool, quite interesting. So the majority of the audience today voted for C, more or less the same, 50% more or less. So yeah, that's quite interesting. It means that if you're more or less the same between alterations and new builds, that's quite a bit of alterations, and we all know it can be exciting in different ways when you're working on alteration buildings. Okay, thanks for that. I'm going to launch another one. I would like to know, have you worked with scan data before? Of any existing buildings or even for as-builts of new builds? I must say I wasn't expecting any votes for always, but I'm very happy to see always. Okay, I'll just give it a few more seconds. I see no one's win for B. No one will ever rely solely on existing drawings, right? That can be a very big mistake. But quite a considerable amount of you voted for A, never always physically measure up on site. And then the majority actually have used scan data once or twice before. Okay, cool. So that's good to know. You guys know more or less what it actually is about, and I'll be sharing some videos and insights to some of the add-ins that you can also use in this workflow as well, which may be of use to you. Okay, so let's start talking about what is reality capture. So I just want to start off by talking about sort of the traditional way, and this is also what most of you have voted that you've done. You get a project and you need to go and do measuring up on site, right? So you head over with a good old tape measure, and that would be measuring up in an analog form where you have to read the value of some sort of device. We do also have some digital tools that are available to make this easier, laser scanners. So the products that we particularly work with is Leica, that they've got one of these laser scanners, but I think one of the ones that is more commonly used is the Bosch one, right? So it's quite cool. It has a nice app with it as well, where you can log your measurements as you go along on site. And this is a digital form of measurement, but it kind of stops there. You still will have to go back to the office and draw it up to create your drawings and your models from there. So what we're going to be talking about in the digital space this time is using another form of LiDAR scanners, and this product actually creates what's called a point cloud, and then in the scan to BIM workflow or reality capture, we're looking at processing this point cloud of data to represent what is in the real world. So if we break it down, scan to BIM, and we look at the scan side of things, scan refers to the hardware portion of it. So you need a physical tool or piece of technology to create this point cloud data. And there are a variety of options that are available. This is just some of the few. And the one that you would choose really depends on the nature of the project, what level of detail you're trying to achieve, also the extent or the size of your building or your project. Some of these scanners are long range scanners, some of them are good for external use, some of them are good for internal use. And so you really have to sort of understand what the needs of the project are before you select the scanner that you're going to use. But ultimately, this pool of scanners will present or result in the same end product, which is a point cloud, and that point cloud will look something like this. So at this stage, it's not a model or a representation of the building in a drawing, but it is a visual representation of the physical space. And at this point, this information is already useful because from here you can do things like measure the dimensions of a door, for example, or the space in a certain area if you're needing to make any alteration. So from this point, you can already make those informed decisions around a table with the contractor, with the architect, with the engineer, and so on. So this is already useful, but taking it further, if you want to move into the BIM sphere, you're talking about building information modeling, and you're talking about your deliverable having intelligent data. So this point cloud will have to be what we call processed, and so now we're moving on to the software side of things, and there are a bunch of different softwares that you can use to do the processing of this data. This data needs to also be checked and validated and stitched together. That's the processing or the registration process. For example, one of the tools that can be used is Cyclone Register. There are others as well, like Autodesk Recap Pro, and there are a few others too, but those are the two that are most widely used. So you've processed this data now, you've validated the data, but you still don't have your drawing or your model yet. So you then need to move on to creating this in an authoring tool, which might be Revit, or you could do this in AutoCAD as well. There are some other pieces of software too, but on the Autodesk side, and the pieces of software that are the most widely used is Autodesk and Revit. AutoCAD. AutoCAD, of course, 2D, Revit, 3D. Okay, so now that we know have a nice overview. When do you actually use this? So we've talked about renovation buildings, and this is just an example of a building that you can see there is a point cloud. So the gray portions on the top, that is an existing, inside of an existing, maybe a warehouse or something with a steel truss. There are some services there too, but the services need to be, you need to make some additions maybe to the services, and that is what's represented by the colorful piping. So those are extracted from a model that you would have created in Revit for your design, and having the point cloud data as a reference, you can superimpose the two and you can start to see how the new services line up with what is existing. In this way, you can foresee any clashes, and this just helps you to save time on that and to get those insights early on before making those mistakes on site. So that is in one instance, one type of project, your renovations, your alterations, and your extensions. But you can also use this workflow in a different sense when you are doing a new build. So at the end of every project, and I'll talk about this a little bit more later on, you have to have a record of your as-builts. And when it comes to things like steel erection, piping, and so on, the piping and the elements will not be on the exact position as what was prescribed in the design. And so where these types of things are critical to keep a record of, perhaps there will be renovations at a later stage or updates at a later stage, this information can become critical. And so once you've completed your build, your new build, you also can come in with your scanner, collect this data via a point cloud, superimpose it with the design model, and that remains as your as-built versus your original design data that you need to or record for your project. So if we look at it, for example, you've got a project. This is an existing building that is on a site that has got some other buildings around it, but this building will be updated. It will perhaps demolished or added onto it, made bigger, added a couple of floors, but you still want to capture what is around the space and which of the elements will be maintained at this stage. So you could be using your, coming in with your scanner, creating a point cloud. This, what that you're seeing is in fact not a photograph, but it is a scan together with photogrammic imagery overlaid over the point cloud. And this will help you to inform your construction. So you use this at the pre-construction phase. You've got your design model as well. You've superimposed your point cloud into your design model, and you can see how the two relate to one another. So that's one instance in which you can use it. Then you can also, as the project goes on, during construction, you can still use this data to enrich your construction layouts as it goes on. And also that helps you to see where things needs to shift around perhaps, or things have shifted around. You have a record of it, and you can compare what is in the design model with what is actually happening on site. And in that way, as you move to the as-built stage after your project, you now have the reality of what has been constructed superimposed with what the intention was in your design model. And so in this way, you can relate your office work to what is happening in the field at all times. And most important is maintain that record for the future. So with what I've said, I'm sure that you can already imagine the benefits, but just to break it down a little bit more and to see, why should you be using this and what are some of the values that can be added to your project. Okay, cool. So let's start off with a typical example. So you now have got a renovation or alteration project, and first things you want to do is to see what the records are. So you try and get hold of some of the blueprints. If you're lucky, you maybe would get some existing drawings from council or so on. Sometimes they exist, sometimes they don't, but either way, you will be preparing yourself to go out to site and actually do some measuring up on site. So you've got all your tools, you've got all your things, your measuring tapes, all your different color pens and highlighters, your notebook and everything. and you spend some good time on site getting all the information. You come back to the office, and this is what you come back with. You've obviously recorded the things that you've measured, any noticeable elements or objects that you've seen on site that might get in the way or be advantageous to the future design. You'll make a note of it, and then you start to draft the changes, right, using what you've taken down, and maybe you've taken some pictures and videos on site as well. So this is sort of like the typical or traditional way of gathering and recording this information. But of course, there are a set of risks that are associated at each stage of this. So just looking at it one by one, blueprints or existing drawings are not always available, right? We know that. Also not always accurate. I've worked on a few alteration projects where there is a host of existing drawings, but when you get to site, what's on site is not actually matching what is on the drawings, especially buildings that was done like in the 60s or there around, right? So you can't really rely on those drawings. And even if they do represent mostly or all of what's on site, in either way you have to redraw it if it's on a PDF format, right? Because it's not in a digital format yet. So you in any case have to redraw this. So we're talking about spending a lot of time. And then that leads back into more time-consuming tasks when you have to go out to site and measure up. Sometimes sites are far away, even 30 minutes can be considered far away because we're talking about 1 hour of traveling during the day. And sometimes you need to take a colleague with you, you need some help. You can't always do this by yourself, depending on the nature of the site. And this is time away from your desk that you could be doing actual billable work. Also, not 100% accurate, fairly good enough probably, but not 100% accurate. You could also miss something. I know I'm guilty of going to measure up on site and be like, okay, I don't feel like measuring that angle and, you know, that type of thing. So, so there's always that risk of missing information. And then also at this point, the information and the time that you've spent means nothing until you've drafted it and incorporated it into a design. So you've already invested so much of your time, yet there's no real value to it until you've actually got that deliverable. Of course, recording these measurements again leads into not being accurate, missing information, of course, damaged or missing notes. This has happened to me before. The page flies off your clipboard, falls into